A warm welcome to you all in my first YouTube video. And today in this video, we are going to discuss a topic of microprocessor, which is assembly language. So what is the definition of assembly language? Assembly language can be defined as a low-level programming language which is used to control a computer's hardware. So in this video, we are going to explore the basics, advantages, and real-world applications of assembly language. Talking about the very first point in this video, which is advantages and disadvantages of assembly language. The main advantages of assembly language is it is very fast and efficient. It has small memory footprints. It has direct hardware access and it has complete control over the machine. And the disadvantages are it is very difficult to program. It is time consuming, machine dependent, and it requires a deep understanding of computer architecture. Now, the second point in this video is the basic syntax and format of assembly language. Assembly language consists of mnemonics, which is short codes like move, add, jmp, and operands like registers, memory addresses, and immediate values. The syntax is readable and easy to understand. The assembly language requires careful attention to detail and thorough testing. Debugging can be time consuming, but with proper techniques, we can find bugs easily and efficiently. Assembly language has a simple format. Each instruction is typically represented by a single line of code, which introduces the mnemonics and one or more operands. Let's discuss about memory management in assembly language. It is mainly divided into three parts. The first one is memory segment, second one is memory addressing mode, and the third and last is memory management techniques. Now, memory management techniques. Assembly language program use various techniques to manage and optimize memory usage, such as specifying the location of data segments, using pointers and arrays, and dynamically allocating and deallocating memory. Memory segment. The memory of a machine is divided into several segments such as code, data, stack, and heap. Each segment has a specific purpose and usage. The last one is memory addressing modes. The operand of instructions typically specifies a memory address. Many different addressing modes are available depending on the instruction set and type of data being addressed. Assembly language is used in a variety of fields. Talking about the real world applications of assembly language, the first one is robotics. Assembly language is used to program the hardware of industrial robots, such as those used in manufacturing, automotive, and aerospace industries. As we know, with in modern world, robots are used widely for the production of different things in the industry. Now, the next one is cybersecurity. Assembly language is used to write and analyze low-level system software, such as operating system, device drivers, and antivirus tools. The third one is game development. Assembly language is used to program the hardware of game consoles such as Nintendo, Atari, and Sega. It is also used to develop games for PC and mobile platforms. Games are quite popular in modern days. So, what's the future of assembly language? Assembly language has evolved and adapted over the years to meet the changing needs and demands of computer hardware and software. It will continue to do so in the future. The need for low level programming expertise will always exist, especially in embedded systems, real time processing, and hardware device interface. New technologies. Emerging technologies such as quantum computing, AI, and AI IoT will require new forms of low level programming, which may or may not be called for assembly language. This is the most interesting part of assembly language, which is assembly language programming with 8085 microprocessor. Talking about the history and overview. 8085 microprocessor was first introduced in 1976 and quickly became a popular choice for the computer developers due to its low cost and ease of programming. In assembly language programming, the human readable code is translated into machine code that can be executed by 8085 microprocessors. The instruction sets and registers. So what is the instruction set? It can be defined as the instruction set is a collection of commands that a computer can understand and execute. It determines the capabilities and limitations of assembly language programs. What is general purpose registers? These are small, fast, on-chip storage locations which is used to hold the data temporarily. General purpose registers are AX, BX, CX, and DX, which are used for arithmetic and logical operations. What is special purpose registers? These are the registers which are used for specific tasks such as program counter, stack pointer, and flag setting. The example of special purpose registers are IP, SP, BP, and flags. Talking about the architecture and instruction set. The 8085 microprocessor consists of various components including the arithmetic logical unit, register, instructions decoder, and mode that work together to execute instructions. It consists of program counter, stack pointer, timing and control, interrupt controller, input and output controller. It has a 8-bit internal data bus which is used to carry the data from one part to another. The instruction set of 8085 microprocessor includes a range of operations such as data transfer, arithmetic, branching, and more that can be executed using assembly language programming. Registers and memory organization in 8085 microprocessor. 8085 microprocessor has various registers that are responsible for the temporary storage of data during the execution of any program. The memory of 8085 microprocessor is divided into three parts: memory, program memory, data memory, and stack memory, and it can be accessed using different addressing modes. Addressing modes and assembly language syntax. There are mainly three different types of addressing mode, which is the first one is immediate addressing mode, direct addressing mode, and last one is indirect addressing mode. In immediate addressing mode, the operand is specified as a part of instruction itself. In direct addressing mode, the address of the operand is specified in the instruction, and in indirect addressing mode, the instructions point to the location where the address of the operand is stored. Assembly language syntax. Assembly language program consists of mnemonics, operands, and commands, which is translated into machine code using an assembler. Talking about the data transfer and arithmetic operations in assembly language. Data transfer. The 8085 microprocessor has various instructions that allow the data transfer between the different registers and memory locations. Arithmetic operations. Arithmetic operations are performed by assembly language programming with 8085 microprocessor, which consists of instructions to perform arithmetic operations such as addition, subtraction, multiplication, and division. This is the last part of our video, which is branching and looping operations. There are three conditions. Unconditional jumps. The execution of the program jumps to a specified address is known as unconditional jumps. The execution of the program jumps to a specified address depending on the condition evaluated is known as conditional jumps. And the last one is loops. What are loops? A sequence of instructions are executed repeatedly until a specific condition is met is known as loop. So this is the end of our video. Thank you.